Hello, and welcome to Part 4 of Hitachi Cable America's Introduction to Fiber Optics. This training presentation is directed at educating Hitachi customers by providing information that develops a working knowledge of fiber optic product technology so that people in the sales channel feel comfortable to include a fiber optic product solution along with Hitachi's copper category cable products. This presentation is comprised of 4 parts. The 4 parts are optical fiber components and types, optical fiber standards, fiber cables and applications, and how to field a fiber cable inquiry. How to field a fiber optic inquiry. This presentation will familiarize you with how to best handle a fiber optic inquiry and what questions to ask your customer to arrive at the correct product design. There is a logical sequence of product attribute selections associated with any fiber optic cable design that will result in the correct cable description. Over the next several slides, we will walk through the checklist process. Quantity is normally the first requirement mentioned. In most installations, the requested quantity is frequently a point A to point B special length suited for specific installation runs. This is very different than copper category cables, which are universally ordered and supplied in 1,000-foot packages and can be used in multiple locations and jobs. Most of the time, fiber cables are cut to length with an over-tolerance of some percentage to provide a level of assurance that the ordered quantity will cover the length measured at the job site. Depending on the size of the cable, cutting of the cable to location-specific lengths may occur at the construction site, at the distributor, or even at the cable manufacturer. In this RFQ example, the total length required, 2,000 feet, and the individual installation put-ups, 1,500 and 500, have been identified. The contractor can choose whether to order this as one reel of 2,000 feet or 2 reels each to the desired length. Number of fiber optic strands in a cable is normally the second requirement mentioned, i.e. I need 2,000 feet of 12-strand cable. Fiber optic cables come in multiples of 2 fiber increments and are commonly available in 6, 12, 24, 48, 72, and 144 fiber configurations. Nearly all network design engineers allow for a number of spare fibers to accommodate possible fiber breakage and future upgrades to the system, and typically increase the needed fiber count to the next available standard package. If a fiber count requirement is not a standard increment, several options present themselves. First, the factory can manufacture what is needed if the quantity meets a minimum manufacturing run, or second, upgrade to the next standard fiber optic count, or third, be satisfied by using 2 standard cables pulled in parallel. Most often, physical plant engineers will select a standard industry-wide available fiber count to be installed. In this RFQ example, a 12-fiber cable is being requested. The third, and one of the most critical product characteristics specified, is the optical fiber type necessary to operate the network. The specifier will first call out the core/cladding dimension, then followed by the fiber spec performance rating, i.e. 50 per 125 OM3. It is almost always a universal requirement that bend and sensitive fiber is included in the callout. Many times, the glass manufacturer will also be specified, i.e. Corning clear curve bend and sensitive fiber, 50 per 125 OM3. Hitachi standardizes on Corning clear curve fibers OM2, OM3, OM4, and OS2 for all its cable designs. Note, between the 50 per 125 fiber types, the highest rated fibers can be substituted for lower rated fibers. So an OM3 can be substituted for an OM2, and an OM4 can be substituted for an OM3. In this RFQ example, the fiber size and performance required is 50 per 125 OM3. The fourth product requirement that may or may not be called out is the buffer type, tight buffer or loose tube. In many cases, it is almost always assumed that in a campus network, tight buffer will be the requirement. As already discussed, a tight buffer cable can be used in an indoor or indoor-outdoor or strictly an outdoor environment. Only when the installation is specified to be an outdoor plant environment on a long-distance run or operating at 1,310 or 1,550 nanometers, it is best to check what buffer type is required. Fiber bandwidth is the same for tight buffer loose tube cables. Loose tube cables offer a slightly better, lower cable attenuation. And given the cable design differences between tight buffer and loose tube cables, it is a good idea to double check the temperature installation ratings of each type and compare what is being called out. Although tight buffer and loose tube have identical operating temperatures, the loose buffer cable can be installed at lower temperatures than tight buffer. In this RFQ example, tight buffer is the requirement. The application callout begins to finalize the other remaining cable options. Whether the cable is for indoor use, indoor-outdoor, or outdoor-outside plant, knowing the application will help zero in on the final cable design. In addition, cable callout may also include the type of application such as suitable for underground duct, lashed aerial, riser backbone, or error handling plenum. As we have already seen, Hitachi designs many cables for multiple applications. In this RFQ example, the cable will be installed indoors. The cable rating will most likely be selected by the intended application. For most indoor commercial use, there will be a National Electrical Code rating of riser OFNR or plenum OFNP requirement. OFNP stands for the optical fiber non-conductive plenum rated. If the cable has any metal conductors or armor, it would be called a OFCP, with the C standing for conductive. An outside plant cable may or may not carry an NEC rating. Hitachi does offer cables that are both indoor and outdoor rated and also carry a plenum or riser rating. In this RFQ example, a NEC plenum OFNP rating is required. Finally, there may be a cable design option added to the callout, such as jacketed interlock aluminum armor, or if the cable is an outside plant construction, there may be a requirement for corrugated steel tape armor with or without a double jacket. Armoring a cable can dramatically increase the resistance to the elements or the unwanted human or animal interaction. It can also eliminate the need for conduit or interduct, saving time and reducing cost. In this RFQ example, an option for jacketed interlock aluminum armor is required. Going through this type of selection process will accurately define the final cable description. The checklist will also identify possible options to consider or substitutions the specifier or the user may not be aware of. In this RFQ example, the cable specified is Hitachi 61337-12, a 12 fiber, 50 per 125 OM3, type buffer plenum rated OFNP with jacketed interlock armor. This slide provides a decision tree and the logical sequence of product attributes associated with any fiber optic cable design, summarizing the choices just covered, which will help develop the final cable description. Though the checklist does not cover every option commercially available for fiber optic cables, it covers the options you are likely to encounter daily. Finally, let's take a quick look at the benefits of including a fiber optic cable requirement as part of a campus network opportunity. As previously demonstrated, fiber optic cables are an integral part of campus networks. Very often, larger projects beyond moves, adds, and changes have both category copper and fiber requirements that will be procured. It is Hitachi's experience that category cables may comprise up to 80% of a network, primarily for the last link to end devices, and fiber cables may comprise 20% for backbone trunk and vertical risers. Fiber optic cabling brings several benefits to the distribution channel to market. First, fiber cabling may represent 20 to 25% of a campus network system. Expanding the product solution to include both copper category cables and fiber optics increases the overall product sales potential. Second, fiber optic cables remain a specialized, non-commodity product, and each cable's length requirement is unique to a specific location within the campus network, often cut to length at the factory to satisfy a specific project request. As a result, gross margins on fiber optic cables tend to be superior than copper cables alone and will provide a higher overall gross margin when combined with copper. Third, fiber cable solutions are part of and included in Hitachi's Open System Architecture (OSA) lifetime warranty program. Fiber cables and associated connectivity can be combined with a copper solution for the same network. All are eligible for a lifetime warranty. Additionally, pursuing the fiber cable portion of a campus network project will increase your overall sales as well as improve gross margins. Thank you for participating in Hitachi Cable America's Introduction to Fiber Optics Part 4.